Hi, this is Dan Benedott. We're going to talk a little bit more now about some of the issues related to the science of nutrition and how data are gathered, and some of the common reasons why people may have nutritional deficiencies. So we'll go through this quickly because later on in the semester we're going to be spending a lot more time on each of these. In the previous slide set, we introduced the idea that there's epidemiological evidence, that is, evidence gathered from groups, and then you find out things from those groups. You have to be a little careful about epidemiological evidence because what may appear to be an association may not really be one. So, an example would be, there's a strong statistical association between the number of books in the public library and the divorce rate. That is, both are going up. You'd be wrong to assume that they're somehow related just because they're both going up. But if you were to look at them statistically, you'd say, my goodness, they're both going up. There's a strong statistical association between the two. So you have to be a little bit careful, which is why you have higher level experiments that can take place with greater and greater controls. And the more controls you have, the more you can control for some of the contradictory evidence that you get in some of these studies, because humans, it can be a little bit difficult. They may not give you the information that's truthful, because if somebody is overweight and you're asking them questions about how they eat, they may underreport how much they eat. Or if somebody has an eating disorder, they may overreport how much that they eat, or they may tell you what they think you want to hear. So you have to be a little bit careful, and the greater the number of controls, the better the quality of the evidence which is there. When you're looking at dietary research, one of the issues is, how do you calculate the nutrient intake that people have? How do you measure food consumption? And there are several ways to do it, but the typical way now is that you use a computer program, you plug in the foods, that computer program is associated with the nutrients in that food, you estimate the amounts, and then you try to ask questions about, are they absorbing the nutrients that they're taking in? Do they have symptoms suggestive that they're losing nutrients quickly? For instance, do they have diarrhea? And you look at all that, you look at the intakes that people have against age adjusted standards and condition adjusted standards. So for instance, there's nutrient intake standards for pregnancy and lactation. If you look at the cover of your book, you'll see the dietary reference intakes, which gives you a very comprehensive listing of the latest standards which are there. So there are quantitative measures, that is, you try to estimate how much people consume. There are qualitative measures to give you an estimate what different kinds of foods are people consuming. So the bottom line is, you're either trying to get the average intake of a group, you try to estimate the at-risk proportion of the population if their nutrient intake might not be quite so good. Another level would be that you're trying to get individual assessments to see, is an individual at risk, and then you compare that individual against standards as well. Typically, food composition tables, which are computerized, are used. And then at a higher level, you would do a biochemical analysis. For instance, if you assess somebody's intake, it looked as if they didn't have very much iron intake, you were suspicious that they might, because of their iron intake, might have an iron deficiency anemia, then you do a blood test to see if in fact they have an iron deficiency anemia by looking at hemoglobin, hematocrit, and perhaps even stored iron like ferritin, to give you a good idea of what the real status is. So that kind of biochemical analysis would be a lot more definitive of the risk analysis that you'd get just from what they ate. Lots of sources of error, depending on where the food was grown, how it was stored, how it was processed, can give you different nutrient intakes for a given food. So for instance, if I have a fresh tomato that was grown in Georgia, that might have an entirely different set of nutrients that as compared to tomato grown in California. They may have the same nutrients, but the amounts of nutrients, different nutrients, might be subtle. Then you add those subtly different. You add those differences together, And over large foods, you introduce some error in the process. You might incorrectly identify food items. So somebody said they had grits, but they didn't tell you that they had grits with bacon, for instance. So you'd be missing out on the bacon. And then you might not have the right amounts either. So somebody said that they had a cup of food. Well, their idea of a cup is different than what really is a cup. So then the amounts consumed can be a little bit off. And then you have differences in bioavailability of different nutrients. So if somebody had a lot more dietary fiber, let's say, in a meal, they might not have as much absorption of certain minerals because the fiber can sequester some of the minerals in the foods that you eat and make them unavailable for absorption. So all of those things complicate a simple dietary assessment, and it's important that they be looked at. Bioavailability is an estimate based on the literature, that is, of the foods you consume, how much of that nutrient is actually digested and absorbed into the system. So we have a pretty good idea based on the literature of what most people can absorb, but there are between people differences in bioavailability based on subtle differences in their system. And then you can compare what people have against standards, so the recommended dietary allowances or the dietary reference intakes, and then you can also make adjustments for specific populations. So for instance, that athletes have a requirement for B vitamins, which is a little bit higher than non-athletes because they're consuming more calories. So the B vitamin requirement is adjusted per 1,000 calories consumed. And people with burns have a higher requirement. People who have an injury have a higher requirement. Pregnant women have a higher requirement for certain things. So you make sure that you make those adjustments specific to the population that you're looking at. In general, the 4 things that affect nutritional status are the adequacy of intake. That is, people who don't have an adequate intake, that is, don't expose their system to enough of specific nutrients, then that can affect nutritional status. Maybe some people take in what they need in terms of specific nutrients, but they don't adequately absorb what they take in. That is, they may have something compromised in their digestion that keeps them from absorbing the nutrients that they take in. So they eat it, but if they don't absorb it, it's as if they didn't eat it, so it just leaves the system. They may have defective utilization. So for instance, they might eat something, they might absorb it well, it goes to the liver where a nutrient has to be converted to an active coenzyme, but they can't make that conversion to the active coenzyme, so they can't use it particularly well. They can't use it the way it's intended to be used. Or they may have a condition where there's increased excretion. They may have diarrhea, or they may have a bleed, or they may have an infection somewhere where they're losing a lot of nutrients, or they may have something in the skin where they're oozing because of an infection, losing a lot of nutrients. So it's those 4 things. That is, do they eat enough? Can they absorb what they've taken in? Are they using what they've taken in? And do they have any increased excretion which might impact their nutritional status? Those are the important things. And what follows is pretty straightforward. So I just want you to look through this yourself as you look through the slide set, and just make sure that you can ask yourself, is it intake? Is it absorption? Is it utilization? Or is it excretion, which is more likely to cause the problem? And if you try to get an idea, is somebody eating enough? You need to get many days if you're looking at an individual for certain things, but not so many days for other things. If you want to get an idea, is vitamin A intake out of it, you need somewhere in the neighborhood of 40 days, depending on whether or not you're male or female. 40 days of intake to get a good idea of average vitamin A intake. On the other hand, if you're looking at energy, you may need only 2 or 3 days to get a realistic idea of what they're actually taking in. So it depends on what it is you're looking at, how many days of intake you'd have to get a rational idea of how an individual might be doing from their dietary intake. Absorption, There are all kinds of things that can affect absorption, drug intake, certain diseases, defective utilization. There can be inborn errors of metabolism where their liver might not be working. There might be drug-nutrient interactions or increased excretion, if you've got vomiting, diarrhea, or something that might cause that problem. So, and increased requirements, of course, pregnancy, growth, stress, burns, surgery can cause a person to have a higher requirement for certain nutrients. So what follows now, and this is what I want you to look through yourself, is um, look at the specific nutrients, what the major problems are, and just ask yourself, is this an intake issue? Is this an excretion issue? Is this a utilization issue? Why is it that people might be at risk, or what are the main reasons why a person might be at risk for a specific nutrient? And then I'll start a little chat on this, and if anybody wants to contribute to the chat, we can get together and chat online and desire to learn. Thank you.